Welcome to Study Loop.
For this problem, we have been given 8 different sequences that we need to examine. And we're going to list the first 10 terms of each. So we're just going to take these in order one at a time. So let's start with A. We want a sequence that begins with 2. So that first piece is easy. And in which each successive term is 3 more than the preceding term. So all we have to do to get from one to the next is to add 3. So that gives us 2, 5, plus 3 is 8, plus 3 is 11, plus 3 is 14, 17, 20, 23, 26, and 29. And I'm just kind of spacing them out this way. We're just going to make a grid of these numbers. So those are our first 10 entries in that sequence. About the second one. The sequence that lists each positive integer 3 times in increasing order. So positive integers start with 1. We list each one 3 times, and we go in increasing order. And since we're doing each positive, we'll start with 1, 2, 3, and then go to 4. So those are the first 10 terms of this sequence. How about C? We want the sequence that lists odd positive integers in increasing order, and we're going to use each odd integer twice. So odd integers start with 1. Since we list it twice, we'll have 2 1s. Our next one is going to be 3s, 5, 5, 7, 7, 9, and 9. Okay, next one is going to take a little bit more computation than these first few. We want the sequence whose nth term is n factorial minus 2 to the n. So if n is 1, that's 1 factorial, which is 1, minus 2 to the first, which is 2. 1 minus 2 is negative 1. Okay, what if n is 2? Well, that's 2 factorial, or 2, minus 2 squared, which is 4. So 2 minus 4, negative 2. 3. 3 factorial is 6. 6 minus 2 to the third is 8. 2 minus 6 is negative 2. How about to the fourth? Well, now we'll start getting some positive numbers. 4 factorial is 24. 24 minus 16 is 8. 5 factorial is 120. 120 minus 32 is 88. And for the rest of these, I would definitely recommend using a calculator. These n factorials are going to get very large. So if n is 6, we have 656. 7 gives us 4,912. 8, 40,064. 9 factorial is 362,368. And if our 10th term is going to be 3,627,776. So they start fairly simple. They get large very fast due to that factorial. Any of these sequences that have a factorial will get large very quickly. Okay, how about E? E is a sequence that begins with 3. So we'll put that in there for the first term. And each succeeding term is twice the preceding term. Well, that just means we multiply every term by 2. 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, 96, 192, 384, 768, and 1,536. So we just multiply each one by 2. Okay, let's come down a little just so I've got some more room to write. Next, sequence F. Okay, the first term is 2, so we can write that down. Second term is 4. Great, we get the first 2 given to us. Each succeeding term is the sum of the 2 preceding terms. So we just have to add, and that gives us our new one. So 2 plus 4 is 6. 2 preceding terms, 4 plus 6 is 10. 6 plus 10 is 16. 26, 42, 68, 110, and 178. Okay, 2 more to go. G. The sequence whose nth term is the number of bits in the binary expansion of the number n. So what I'm going to do, just to make this one a little bit easier, is I'm going to take a moment and in red, I'm going to write the binary expansion of the number n, and then underneath it, I'll write the actual sequence. So 1, 2. Remember, in binary, we only have zeros and ones. So to write a 2, we put a 1 in that second place. So that's 2. 3. Well, now we have all ones. We have to add another digit. 4, 5, 6, 7. It's all ones. We have to add another digit. 8, 9, and 10. Now, if this is confusing, if you don't understand how the binary works, the problem does recommend looking at section 4.2 just to kind of look ahead and see how the binary works if this is unfamiliar to you. So the actual sequence, though, is not the binary numbers. It's how many digits are in this binary expansion. So my actual sequence here is going to be 1, 2, 2. These next numbers all have 3. And then we have 4. So the black numbers are the actual sequence for this problem. And H. The sequence where the nth term is the number of letters in the English word for that index n. So 1 has 3 letters, as does 2. 3 has 5 letters. 4 has 4. 5, 4. 6, when we write it out, has 3 letters. 7 and 8 both have 5 letters. 9 has 4 letters. And 10 has 3 letters. So these are the sequences A all the way through H for this problem.